Black holes are scary objects roaming in deep space and swallowing anything that comes near them. White holes are also not less terrifying, but they come in different sizes. The first white hole has been finally discovered by scientists. They have found the proof after years of assumption and research. But what is a white hole, and why are astronomers so excited about it? Stay tuned and learn everything that you should know about white holes. Stellar black holes can be up to 20 times bigger than the Sun's mass, but they are very small. They exercise a strong gravitational pull on other objects. Every large galaxy includes a supermassive black hole at its center. Scientists think black holes were created in the early universe after the Big Bang. Stellar black holes are formed when the center of a very massive star collapses in upon itself. Scientists can see the consequences of a black hole's strong gravity on stars and gases around it. When a black hole and a star are revolving close together, high-energy light is generated through it. The Sun will not become a black hole, but it will die in billions of years. After that, it will become a red giant star, a planetary nebula, and then a cooling white dwarf star. White holes are the exact opposite of black holes, and they are regions in which space-time flows inexorably outwards. If a crew tries to enter a white hole, the thin force of the gamma rays would destroy them and their ship. The theory of white holes. The theory of white holes was found due to the mathematical fascination with black holes. Carl Schwarzschild utilized Einstein's field equations to find the equation of mass in empty space-time, which is a mathematical manifestation of a black hole. Schwarzschild invented an equation for a black hole that does not change in size and has always existed. By overturning time, we can get a white hole. Some scientists doubt that white holes exist, claiming that while they follow general relativity and are mathematically sound, they disobey the second law of thermodynamics. The small decrease in entropy can arise as long as the universe's overall entropy is increasing. Black holes are great at increasing the mayhem of space, but white holes, which eject matter, violate this law. If black holes could not evaporate and shrink due to the limitations of space-time, they would transform into white holes. NASA's Swift satellite saw a gamma-ray burst in 2006 that lasted for 102 seconds. However, it did not seem to be associated with any star explosion. Still, some years later, scientists launched the hypothesis that GRB 060614 could have been a white hole. White holes were thought to be a figment of general relativity, born from the same equations as their collapsed star brethren, black holes. However, some theorists have been interrogating whether these twin vortices of space-time may be two sides of the same coin. To a spaceship crew seeing from afar, a white hole looks like a black hole. It has mass, it might spin, a ring of dust and gas could gather around the event horizon, the bubble boundary dividing the object from the rest of the universe. But if they kept seeing, the crew might notice an event impossible for a black hole, a belch. Carlo Rovelli, a theoretical physicist at the Centre de Physique Théorique in France, said that it's only in the moment when things come out that you can say, "Ah, this is a white hole." Physicists depict a white hole as a black hole's time reversal, a video of a black hole played backwards, just as a bouncing ball is the time reversal of a falling ball. While a black hole's event horizon is an area of no return, a white hole's event horizon is a boundary of no admission. No spacecraft will ever enter the region's edge. Objects inside a white hole can flee and interact with the outer world, but since nothing can get in, the interior is cut off from the universe past. No outside event will ever influence the inside. James Bardeen, a black hole pioneer and professor emeritus at the University of Washington, said, "Somehow it's more disturbing to have a singularity in the past that can affect everything in the outside world." As white holes are assumed to be closely related to black holes, there are many theories as to how they might get created. The theoretical heritage of white holes can be drawn back to Russian cosmologist Igor Novikov in 1964. Novikov came up with the intention of white holes as a sort of cosmic twin to black holes as part of a solution to Einstein's field equations, building on the work of German physicist Carl Schwarzschild, who characterized the space-time geometry of vacant space surrounding any spherical mass. Schwarzschild's solutions to Einstein's field equations include the projection that if a mass were compressed inside of an essential radius, then its gravity would become so intense that not even light could exit. But Schwarzschild's explanation also included the possibility of a theoretical twin for the black hole known as wormholes. It folds in space-time that objects in space can theoretically pass through to near instantaneously cross great extents in between the event horizons of a black hole, and a theoretical negative addition of the singularity. Some scientists suggest that once a black hole grows small enough, it could adapt to a white hole. This white hole would be tiny on the outside, but the inside would contain much of the information gulped by the black hole, which would then originate over time. Still, many of these scientists have suggested that the explosion of the Big Bang has been the emergence of information from a white hole. Well, that's it for today. Don't forget to hit the red subscribe button so that you never miss out on any of our videos. See you soon. Thanks for watching.